Hi, in this video I wanted to show you how to use Python to extract data from PDFs. And I already have another video out there that does that, but in this one it's going to be a little bit using technologies that I use more professionally, and it's going to be a trickier case than the PDFs I've extracted in the past on YouTube. So we're going to do restaurant menus, and I'm going to show you, at least in this tutorial, how to do a PDF menu. This is all part of a grander project I'm working on to extract menus across the internet that are either in PDFs, web pages, or something else, and then trying to scrape that automatically and find new menus to explore so you can get an idea of all the current ingredients and entrees, prices, and locations of things. So without any further ado, let's begin. Oh, also, if you do like this content, please obligatory like and subscribe. Helps me create more things. Any of your feedback helps me focus more on things that you will like more. So if you like something, tell me about it. If you think I should do something else or should focus on a different project you really want me to see done, let me know and I'll work on it. Anyways, like I said, let's begin. So we're going to be using a few different libraries. We're going to be using Poppler. That's a library that's on Unix and it's been around for a while. It's great for manipulating PDFs. Then we're also going to use a geometry library in Python called Shapely. And we're going to create our own layout algorithm instead of using Poppler's. This should come in handy down the road if we're scraping from websites or other things, because Poppler is a little bit more rigid in that regard. And here's the menu I found. So I live in Las Vegas, and I wanted to do Gordon Ramsay steak. I ate there once before. And here's the dinner menu. So as you can see, it's a pretty normal menu. It's got some standard layout. You can see this text appears to be consistent. You see a bold text with a price to the right. The red denotes category. And then the italicized is the description of the items. So it looks pretty straightforward. We will find some issues as we go through it, but I'll show you how to parse out this first page here. That's the menu. We're doing the dinner menu. And first off, here's how you request a PDF in Python. It's just like any other web request. You can just do request.get, super simple, the URL, and then that content. This is what a raw PDF file looks like when you open it with the text editor. So that's that there. And we're going to work with Poppler on this PDF. So we'll download it. And by doing that, we're just opening up a save location temp.pdf, and we'll write out this binary, these bytes here. And that'll be our file. Okay, and like I mentioned before, this is Poppler. So here's their sort of overview. Feel free to read that on your own time, but it's been around for a long time and has a wide variety of support. It's super helpful for extracting the location of text, what was used to create that text, the fonts used, the size of things, and sort of my favorite favorite PDF library. And I found this library I haven't used before. It's called Poppler in Python, and it tries to wrap around the Poppler binaries. So what that means is Poppler is something that you just run, Poppler like a command. It's not like in a language. It was written, I believe, with C or C++. But to interface with it, most people just run the binary. You say PDF to text, do that here, and then Poppler does its thing. Now, since it's not written in Python, the way people work with it is through a binding. So this right here was sort of call those things behind the scenes for us, and then return the results in nicer Python objects. This is the first time I really used this library. I really hope it catches on, and maybe I'll even contribute to it, because it is a pain to deal with binary output in Python. Okay, so we're going to load the data. You can see rest.content. We were able to do that actually without using the save file. That was able to happen all in memory there. So again, we're not using the temp PDF, but storing that just to be safe. And to work with this library, it helps to use the help command. Python has this to tell you what methods are available to you. Some of these libraries aren't very well documented. This is a good example of one that isn't too great. It's not bad, but it doesn't document everything you need. So it just has sort of some happy paths done, but not everything. So by using the help document here, I was able to find something that looked interesting, fonts. I wanted to know what fonts were used in this, and maybe those fonts can help me determine the menu layout. And sure enough, we have italic, bold, and italic. I think I said that right. Yeah, there's three: italic, bold, and then non-bold or regular. And there's a few other things that are useful here. When it was created, when it was last modified. So we know Gordon Ramsay and folks last modified this on the 28th of March. That's pretty interesting to know if you're just like trying to do some restaurant intel. They change the prices every couple months. It looks like some people might be quicker, some might be slower, but that's kind of cool to know. You can also see it was made within Word on a Mac. Kind of cool if you want to learn about, the software stack of restaurant building. Apparently not too sophisticated in this case, but, it gets the job done. Word is good software, just like Excel. Next up, we're just going to start with parsing the first page. In this video, I'm not going to do multiple pages, but to do that, you would just change this to create page here, and that would give you a different page. But I found that create page, and then we have a page object. In the page object, I see page rectangles. You can search on that page, and then you can look at the text. First off, let's just look at what the PDF looks like. So here I'm just rendering it. Pillow is a library to use in Python to help work with images. So if we just run this code here, I believe this comes from the actual package itself. We get a pillow image, and then we can just display that. So nice to see everything looks about right. Here's the menu on Gordon Ramsay's site. And here it is on our coding environment. So everything looks to have come through okay. Don't mind how it looks a little bit pixelated. That's just because of the rendering not set up perfectly. The main thing is the gist of the text looks right. Next up, I played around more with the help. Really just every single little thing you work with the library, just hit the type help, and then it'll show you all the methods available to you. Also, autocomplete is kind of nice, or if you're using a IDE like PyCharm, you can go into the source code yourself. And you could also go on the GitHub too to find this, but I find help is pretty handy. So here we go. We have the text list that contains font information. Looks like it has text. If the text is rotated, so all pretty useful stuff. Has space after is kind of useful. And then we can also look at VBox. So that returns the height of this, what's the word, theoretical rectangle and where the text is. And I'll show you that in a second. But we have everything we need to sort of draw rectangles around text and begin to create some scraping algorithms. Also, this is a nice way to look at how the text comes through with Poppler. Say you're on a terminal machine, or you're just coding and you want to see things kind of clearly without any fluff. The physical layout option from Poppler works well for that. And they even date the menu, so not the best intel that we came up with earlier, but still kind of cool. Next up, we're going to convert the image to a NumPy matrix, because that'll be easier to work with. So if we have a NumPy, a NumPy image, we'll be able to do things on a pixel basis more easily. So this is what an image actually looks like behind the scenes. You have, intensity values that could be color, and then they're all organized throughout the PDF or the image. So for viewing this as an image, just a sec here, you can see the shape of it. So it's 864 pixels tall, 504 wide, and then 4 deep. So that determines like the color and the intensity, I believe. And if we want to draw the image a little bit better, you notice that pillow one didn't really, or that NumPy one didn't work too well. Pillow was a little bit better. If we're working in NumPy, it is best to do something like this. So just make the figure size bigger and it'll auto scale with some default arguments. I left them here commented if you want to play around for things. But anyways, we showed that we can see the text on a PDF and we have an image. Next up, let's begin to parse this with Python. So to start with, I've created this whole big grid of the text on the PDF. We have, how big the font is, what the text is, and then the locations of the bounding boxes. So this shellfish should be at sort of the top left. X and Y values are pretty small. And you can see the font size is around 10 point. And then it's in bold, but not italicized. And by using this information, we can begin to parse the PDF. So to start with, I've just created a parser that goes by using the bold information and grouping by the Y value. So in that case, shellfish platter should be grouped together because they have the same height at Y value. And I'm just going to print out that whole big long string of things in the same line. And if it's bolded, I believe that should correspond to a menu item. It's following this format here. I'll show it actually on the website. You can see shrimp cocktail, that's a menu item. Half-pound Alaskan king crab, that's a menu item. And it seems like that bold rule is pretty good throughout the whole thing. Sauces does not work, but everything else looks pretty good. Okay, so we got the text. Now here's the menu items. So I added this height greater than 10 as sort of the max height for all the boxes on the same line. Found that just sort of seemed to be the height used of everything, so I just added that in. And this is how you can combine text by putting a space in between everything. So on a quick glance, these all look like menu items, except this caviar. I don't believe that was a menu item. Pushing back here, we go to caviar. Yep, that's its own thing. That's a category. So one thing we may need to add is something that determines where the categories are and where the menu items are. And that should be pretty standard for most menus. Some will probably be easier than this, but underline is a good thing to look at. And then another thing, notice how this menu has two columns. And if we look at our order of things here, we see that shellfish and Japanese A5 got put on the same menu. Sort of missed that in my first look here, now that I'm doing this again. So what we want to do now is recognize that these are two different columns. And by doing that, we'll be able to separate out the bolds and not have any overlap across the line. So here we go. To determine columns and put things in the right spot, a rather simple algorithm. So we're going to say there's two columns, and we'll say take everything, half at the midpoint. So that middle point down the line here. Anything to the left of that should be in column 1. Anything to the right of that, column 2. And we can get the width of the picture by doing this numpy.shape image yx color. So we're just going to be looking at the x value. And this is how you do that with numpy. Again, another good reason to use numpy is it lets us do things like this more easily. So this is sort of the breakpoints. This list here says there's one breakpoint that we're going to bin things in. Anything to the left of this, we will put in one bucket. Anything to the right, we'll put in another. And I did sort of offset it a little bit by the font size. I thought that might be helpful. It didn't really make a difference though, but just keep it unless you have a reason not to. Okay, so now we have a new column for column, and it's 0 and 1 because computers start at 0. Next up, let's see how our column recognition did. I'll show you how to draw on your picture, and this is how. So we're using a matplotlib. Oh, actually I should get rid of this. We're not doing that. It's kind of a pain to work with. So I've just hard-coded some colors here. This is RGB. So the RGB. And I think they're kind of inverted with CV2, so just know these are sort of core colors that got flipped around. So we have a blue color in the first column and a green for the second. Everything looks great to me. If we had an issue, we would see some blue with the green or some green with the blue, but it looks very well columnarized. Say that's a word. And the code should be pretty straightforward. The only thing of note is this int here. So when working with pixels and slicing a matrix like numpy, you have to make sure everything's an integer. It doesn't work if you try to slice an array by using floats. So that's why this list map int is in here. Yeah, I'll just show you what that looks like too. So see, it just turns it into slices. All right. Next up, let's use that column detection to do better menu item detection. So we're just adding a very simple column to our group by, and that will automatically split things out. So it'll do the first column first, second column second. So we have shellfish. Notice we don't have that A5 in there anymore. Before we had shellfish Japanese A5. Now we don't, so that's good. And everything looks a bit better. So pretty pleased with our quick and easy column detection. Next up, let's try to load in prices. Maybe those will help us determine what's a menu item and what's not, because shellfish doesn't have a menu item, or doesn't have a price. but shellfish platter does. Half-Maine lobster does, so it should be a helpful indicator. Just run the image again so you can see and so I could talk over it. Now here's how you use Shapely. We're going to first create a Shapely box object. So this is how you do that. I called it bbox. That stands for bounding box. Just like we had before with these rectangles, we're just going to put these in another Python library that can work with rectangles and detect if they're intersecting or other things. So here we go, convert it. That's just how you do it. You could read it on the Shapely docs. It goes by the xmin, ymin, xmax, ymax. And there we go. We're just going to put that in the pandas data frame. These don't serialize right if you go to CSV and read CSV, but if you're just using them all at the same time, they work great. So just make a note, bbox probably won't work very well on read CSV commands. All the other types are pretty normal, so that's good. And then we're going to add a new column here, is number. This is a regex. It just says this is a digit, so 0 to 9, and then a dot symbol. Look like all the prices I saw here with Gordon Ramsay. So there's no dollar signs in any of his prices. We just have this information. So if that's present, and that's all that's present, so it starts with it and it ends with it, and there's at least one or more in the word, then we know it's a number. So I just created a new data frame called prices. That's all the ones where the is number column is true. So now we're going to do the same code as before, but we're going to add in prices. I'll walk through how this works. Oh, what happened here? Oh, I forgot to run something. Here we go. So before we had this code, item text, sort of joining everything together. Now we're adding a new thing. So with everything we combine together, the same text, we're going to do this cascaded union operation. And what that does is it combines all the boxes together to create one overlapping region. So since we combined shellfish and platter together, those should have a bigger rectangle than just one. So that's all that cascaded union does. And in the menu items step, we just add those to text boxes. Then also we're just going to take that box and then slide it to the right. That's how we're going to be able to pick up the prices. So that's this translate step, handy thing from Shapely. And then the scale step. So if we're looking at a PDF and we're trying to find, where things intersect, if we take Caesar salad and we want to slide it, to the right a bit, we could just use that. But you actually get better accuracy if you sort of shrink that intersection zone, because that'll avoid issues where like a P from the above might overlap with the bottom line or things like that. So it's a good practice to kind of shrink and add a little bit of padding to your intersections. So we added that in, and you'll see if I don't have that, we'll mess up something with potatoes. Where's the potatoes here? I believe it did. Let's see here. Maybe I fixed it with my columns, just a sec. Oh, yeah, we're adding prices. So we see sides has 16 as the price, and potato has 16 as the price. But on the PDF itself, sides is the only one that should have the 16. And it should be 16.95. I'm going to increase this. That's an issue. Let's see, do a little live coding here. Why is that? We get 16 flat and 9.5. All right, well, I will fix this before I upload. Don't want to go digging too hard now, but the gist of it is I'm probably missing the 0.95 somehow and adding that to the potatoes, or sorry, to the sides. So I'll fix that before I upload. If that's not the case, I will, fix it by having a better intersection zone. And I think actually that might be the issue now that I come to think of it. 0.8. So that gives me the 16. And then if I create this a little bigger, nope, still didn't do it. Oh well. I will, like I said, fix that one. Everything else looks mostly good here, so okay to proceed. And Next step I wanted to do is, oh, sorry. I said one thing and did a different thing. We're going to put this scale factor back in so the sides are appropriately taking that 16. Now, another thing you can do when parsing things that only belong to one thing, you can just remove them from the set of things that could be a possible value. So what I'm saying there is there's only one 16 that has that 16 and the 9.5 together. So if that is taken, just remove it. Don't allow it to be used by potato puree. That's another approach to go through that, and it works pretty well too. Anyway, so we get the intersection, and then essentially here we just combine all the spots where price intersects. I joined the text all together without any splitting because I want to handle decimals like the 9.5 and the price. Unfortunately, it was missed on that one, but the others it was able to be gotten. So I will fix that. Anyways, last step, we're going to add in the menu descriptions. So looking back at the PDF, draw image, we can see like this Jadori chicken breast. That text is in italics, and using italics for a description is a pretty good rule here. So we're just going to use that. So here we go, just like we did with menu items, we're going to do text df where it's italics. And to add this in, we're going to have to do this after the fact based on the nature of sort of the algorithm. So we can't sort of look back appropriately unless we have everything known where the tops and bottoms of the menu items are. So I'm just adding in that information to menu items, the top and bottom information, and then the column location. That's the only changes here, besides some comments and other things. And then here's the algorithm to take all that text and find the nearest menu item above it. And that's what will get the description. So see here, I'm filtering by menu items with the same column. Here I do element, so the individual description minus the bottom of the items from that column that are possible menu items. Then from there, we're able to take the smallest one, that's positive. So we don't want to get anything that is so small that it's on the other side of it. We want everything below. So that's why this is if greater than 0. And then here we just get the smallest value, and this sub 0 tells us to take the index of the menu item. And then once we have that, we'll just make a data frame and then join it on the same index. So we can see some things have a description, some things don't. And by calling the join operation, it'll be nans, not a number, when it's not present. And then if it is present, we'll have values. And yeah, this looks pretty good. So if you want to know what a Osetra has in it, it's a red onion, egg, chive, creme fraiche, and blini. So sounds good. And yeah. Also, we can see the steaks don't have a description. It's pretty self-explanatory, I suppose. The menu item for, what is it? Oh, never mind. But yeah, there's still a couple menu items that have some issues. So like signature served medium rare, garnished with a glazed root. Let's see what's going on there. So see, this roasted beef Wellington did not get matched appropriately. It got the vegetables, potato puree, red Remy, red demi. Yeah, and that got matched to signature. So I think the issue here is our bottom isn't working quite right. So we might want to offset our bottom by just a little bit. So if we make our bottom slightly smaller, let's make it like 2 pixels smaller. Maybe that will fix things. Served medium rare, garnished with a glazed root. Roasted beef Wellington, vegetables, potato puree. It looks like the two things aren't allowed to have the same parent. This is another small issue I guess I need to fix. So I will, again, fix that beforehand. What's probably happening is this below. Oh, let me just, I'll give it another try here. Live coding is kind of tough with this stuff because it's very nuanced. Sometimes you just have to display it and then you'll be able to find the issue. So just a sec here, bottoms dot max. Maybe I do -5. And let's see. There we go. That looks better. So yeah, my bottom was a little messed up, and the text was sort of matching, I think, because this might have went a little bit over, and then served medium rare bound signature was above because my bottom was a little too sensitive. So by changing that to go with 5 pixels or so, that solved that issue. And yeah, so most of the descriptions look pretty good. There's still probably some issues, but as a first pass of creating PDF software, PDF extraction software, this is pretty good. In the real world, you can't really trust your algorithms to work 100% of the time. So what is often done is this thing called human in the loop. Let me just search it for you. So I guess sort of what it describes is, human always looking over things. So, never make a prediction without a human on the other side. In this case, with data generation, so we're sort of extracting PDFs and generating data based on that, it can be good to, always have that checking what the AI is doing and detecting things. And what you can do is you can show a human, hey, here is the item I found, this is where it is, and what was found is the description. Is that right? And that becomes a lot simpler of a problem than giving someone a whole menu and making them transcribe it. We've already pre-filled in most of the values. It would just be some minor edits here and there that a person would have to do. So as it gets more sophisticated, you could sort of show a snippet of an image. Maybe we're trying to say, hey, is our roasted beef Wellington correct? And then we would be able to take our bounding box information, generate a small image, and then give that to a person or some other model to fill in the blanks there. So yeah, perfection is never necessary, I would say. I mean, sure it can be, but it's very cost prohibitive and difficult to get something really perfect. But if you can get sort of an 80-20 solution and create a process to work with that data, you'll do much better at having a successful project. Also, when you're working on this, I'm working on this on my own one time. There's not too much of a business need for it, so it's not a good idea to get so stuck in the weeds trying to make a perfect parse of this menu here that you stop all other progress. It's good to sort of say, okay, I've got PDF parsing code. Maybe I'll do web scraping code, and then I'll do scraping code. Then I'll connect them all, and then over time I'll figure out what piece needs the most improvement, because this is already good enough to do sort of a preliminary database on menus. I just need to feed it more PDFs, come up with like a template for doing this, and things will get better. But for now, it's not a good idea to get too fancy on just one PDF example. And hopefully we'll see some easier PDFs too, because this one's pretty easy, but there's some weird things like the platter having 2 people, 4 people. That's like a special case we'll learn more how to handle as we get more experience with PDFs of this nature, so many PDFs. And then underlined text, we might need to figure out, hey, we need to add this, so I might have to create a PR on that, a pull request on that library I'm using to add underline, because that would be super useful on this menu. But other menus, maybe it's less useful. They use different fonts or different sizes to denote the categories, like an appetizer section. Anyways, thank you for watching. This is first tutorial on how to scrape data using PDFs and doing it with Poppler and a geometry-based library. So it should be much more flexible than the approach I showed before. And I hope it gives you a good starter base to try scraping PDFs of your own. A good exercise if you want to see if this actually works or how good you are at doing this, I'd recommend just scraping the dessert menu here. So we can see it's pretty similar layout to before. The prices are to the right, and then we see actually bold and then not italicized, and font size is different, but it should be all very straightforward for you to handle and do as an exercise to prove you know what you're doing, if you're interested. Anyways, thank you for watching. Again, like and subscribe. Let me know your feedback and any projects or things you'd like to see me do. Thanks.